Alright, this chapter is a review on inverse, exponential, and logarithmic functions. So real fast, let's take a look at inverses. So we abbreviate it f with -1 of x, and in algebra with that -1 would mean 1 over your function, but that's not what this means when we're looking at functions like this. So it's not quite like algebra. Like if you just put 1 over it, then that's not what the inverse is going to be. What the inverse does is, let's say you have some function that when you plug in the number, like let's say you plug in 6 over here and out pops 3. Well, what the inverse does is it sort of works the function backwards. It's going to say if you put in a 3, then it's going to get you back to wherever you started, the 6. So that's the inverse. Think of it as sort of working backwards with the function. So the way that we solve these is fairly easy. Let's take an example. Let's say, how about square root of 2x minus 3. All right, so first step that you're going to do is kind of an easy step. You're going to, instead of f of x, just put y. So you're going to make that into a y, and then everything else stays the same. Then the second step, you're going to switch the x and the y, and then you're going to solve again for y. So let me show you here. So instead of y, we have x. So I've got x equals the square root of 2y minus 3. And then I'm just going to put a little note over here of what we did. Switched the x and the y. All right. So then now it's, again, just kind of comes back to a little bit of algebra. Now we solve for y. So looking at this, we're going to take the square. We're going to square both sides. So I've got x squared equals 2y minus 3. Then I want to get y by itself. So I've got to get rid of that 3. So let's add 3 to both sides. Got x squared plus 3 equals 2y. Then last but not least, because I'm solving for y, oops, it's a little crooked, I'm going to divide by 2. So I've got x squared plus 3 over 2 equals y. So then that's what I'm looking for. So I got it back to y. So I got y by itself, so I solve for y. So then I can come over here and I can say the inverse of this equals x squared plus 3 over 2. Voila. And so that's finding the inverse. You're just flipping the x and the y and then solving for y. And let's take a look at this one in action, just to kind of show you what an inverse does. So if I have f of 6, so that's this one. All right, I'm going to have, I think this will work out. So we'll have 2 times 6 minus 3. So 2 times 6 minus 3, well, that equals 12 minus 3, so that equals 9. Square root of 9 is 3. All right, and then so if we put this, so if we do f inverse of 3, I should get back to 6. Let's see if it works. So here's my inverse equation. So I've got 3 squared plus 3 divided by 2. So 3 squared plus 3, that's 9 plus 3 is 12. 2, so that equals 6. So our work, whoops, sorry about that, everyone. Let me go through, there we go. Let me go through that again. So we had f -1, the inverse of 3. So we did 3 squared plus 3 over 2, which is 12 over 2. So that equals 6. Check. So I plugged in f of 6 and I got 3. I plugged in inverse of 3 and I got back to 6. So you can see how those inverses kind of work. That's sort of what we're doing. Now let's graph this. I'm not sure if this will work out graphically quite as good, but let's give it a try. Y equals, okay, so if I do the square root of 2x minus 3. Yeah, this one might be a little bit ugly. Just to kind of help us sort of visualize what's going on here. I'm going to do that other side. Okay, so here we would have, now let's put our inverse up here, and we'll see what it looks like. Oops, let's do y equals 3 squared plus 3 divided by 2. Where did it go? Oh, sorry. That should be... Sorry, technical difficulties here for a second. Oop, I got 3 on the brain. X squared. Okay, much better. All right, so now we're in business. So if you can see, or to kind of visualize what's going on here, when you take an inverse, there's going to be a 45. There's going to be a line. Actually, it'll be right like that, a 45-degree line. So when you do an inverse, it's going to flip this graph. It's going to mirror it along this 45. So it's almost like if this was wet ink on this side of the page, and then you folded it along a 45-degree angle, the wet ink would be over here. So, so this side is going to correspond with this side, and this side is going to correspond with that side. So that's kind of when you see him graphing. It's not like a vertical or horizontal. It's a 45-degree angle, and it mirrors it over on that other side. Okay, so let's take a look at, while we got this up here, let me delete all this. All right, so let's take a look at why we're lumping logs and exponents in here, because all that a log is the inverse of an exponent. Okay, so let's say you have y equals 2 to the x. There we go. So you'll see how this goes through this point 1 right here. Then let's do y equals, and I think we can do it down here. Let's see, yep, log base of 2 to the x. Voila. And then you see here, see how this goes through 1 right there. So all of these logarithmic functions, like let's say we did log 100 to the x. No matter what it looks like, even though like this one's kind of funky, they're all going to cross through here in the exact same way that these ones, so here's the inverse of it right there, are all going to cross through 1. So you see, again, we have our 45-degree line, and these both are mirrored across that 45. There's the one, there's the other corresponding one. And so you can see why things that we went over before, but I believe they're covered in this chapter, like one-to-one functions and all that, now become, now start to, I don't know, maybe make a little bit more sense when we're looking at inverses. One last thing that I want to cover in this chapter, and that is, let me bet you we can do it. It's not going to take up much room. All right, so we're gonna this constant e, and I just want to kind of go over real fast what exactly it is, because it's kind of cool, right? If you take so all that it is going to be 1 over 1 plus n to the n. And we're going to take the limit as n approaches infinity. Or another way to do it, you can write it as a summation. It's the summation from 0 to infinity of 1 over exclamation n. No, that's remember, that's like if it's 5, it's 5 times 4 times 3 times 2 times 1. So 2 different ways to write this, and they've figured this out to, I believe it's like 1 trillion digits, but just keep in mind that it's one of those irrational numbers that they'll never really get to the bottom of. So, but if you're ever wondering, like, how we what exactly it is that we're doing when we talk about E. Let's see, 2.71. I think it's like 828 something something something. It's a really, really important number, a really kind of neat mathematical number. But if you ever wonder how it's calculated, well, there you go. Has a lot of different applications. So, all right, that's kind of a wide brushstroke of this chapter, but hopefully it should be a little bit of a review, kind of jogging the memory a little on these inverses and logs and exponential functions.